virtual students can see this. And I'll hand out this sheet. So as I go through this, you can jot down any notes if you decide maybe today a class sounds interesting or that's what you think you're going to sign up for. Maybe you can give yourself some options. But with science, unlike some other courses, after this year, you're going to have a lot of options. There's no like specific, there's no specific junior science course here. All right, so if you're here in chemistry, you have taken and passed biology, so we'll skip that one. So chemistry, you guys are all in that now. If you pass both semesters of chemistry, you are done with your required courses. All you need is a third elective. It can be anything except looking at the sheet here. There's only one class that you cannot take until you're a senior, and that's PLTW, Medical Interventions. But any other class you have the ability to take once you pass chemistry, okay? So you could take any of those classes that have the white box for sophomore, all right, or junior, or senior, except for the Medical Interventions one, okay? So I'm going to talk about each one a little bit. So physics, there's going to be two options next year. We have physics and honors physics. All right, regular physics here is just algebra 1 based. All right, it's investigation based, meaning that you're going to be doing lots of labs and hands-on activities. All right, there is obviously going to be, since it's algebra 1 based, there's going to be some math involved. All right, but I know Mr. Leckwitz teaches it, and he does a lot of labs, and sometimes they're really big labs where it might take you like an entire week or two to go through the lab. So every day is a lab day. All right, there's honors physics, algebra 2 based. All right, so the math is a little bit more intense there and more in-depth discussions. All right, but they're covering the same basic material. Physics is really investigating energy and matter. All right, and we talk about matter in here a lot. We haven't talked about energy a whole lot. We will later in the year, but physics really dives into those differences. Before I go on, I'll just check after every slide because you may not remember all of this. So if you want to write down any notes on your sheet, you can do that to remember. Do you have any questions about physics? All right. PLTW stands for Project Lead the Way. There's a bunch of Project Lead the Way courses. You have the ability to earn college credit by taking these courses. So they are similar to like an AP course, but they're not AP. It's a different company, and this is more project-based. There is a test at the end of the year that you would have to take, and then there are some other things with it, but there are 3 PLTW courses that you have to kind of take in order if you want to take kind of that branch, all right? So if you're interested in becoming a professional in the medical field, so that would be nurses, doctors, those types of things, this is a really good branch for you, all right? So principles of biomedical science, all right, human body systems, and then medical interventions. This is the one you can only take as a senior because you have to go through these 2 courses first in order to get into that 3rd course, all right? And it has some descriptions here. So engaging activities, you're going to be dissecting a sheep heart. Students explore bio and medicine to determine factors that contribute to a person's death, all right? And this is a fake person. They're not actually going to study someone who has died. All right, human body systems. All right, identify skeleton using forensic anthropology and DNA analysis. Interactions of human body systems through the use of mannequins, and then apply a note to solve real-world medical cases. All right, so you can only take this if you pass this one. And then medical interventions. Mr. Gerber teaches this one. Mrs. Duke teaches these 2. And I've seen some of the labs that Mr. Gerber runs in here, and they're pretty cool. They're pretty intense labs. And if you're into the medical field, I suggest taking a look at this path. And then principles of engineering. This is a course that I teach. So students explore a broad range of engineering topics. We're going to take a look at mechanisms, strength of structure and materials. So there is some chemistry, kind of the things that we talked about, how the chemical structure of something is going to make it different. And if you're an engineer, you need to decide what's the best material to build something with. Sometimes it could be wood, it could be metal, based on different things. All right, automation. So we do make robots. All right, we use motors and they're called servos and lights and different things, and we can build a little robot that can do a small task. And we write code for this automation. And so we learn a little bit about coding in that. Then we apply what we know to take on challenges, and we design like automated machines and different things in the class. This class is based on projects and solving challenging problems. So what I really like about this course is it shows you a lot of different things that an engineer is going to do. I think it's like super, super fun, but it isn't just projects. There are like things that we have to do mathematically and show, and there are challenging problems in there. But I think it's totally worth it. It's a tough course, but it's really fun. All right. So in order to make sure that you're ready for the course, you should get a C or higher in geometry. If you haven't achieved that, maybe a different or going to physics first might help you a lot. So these things are going to help you a lot, but not required. Okay. So if you're in physics or honors physics, that's going to give you a lot of background to help you in engineering. And then there's an introduction to engineering and design, which is in tech ed classes that also is the same PLTW kind of structure. And you should be interested in the engineering field, have some sort of interest in it. And then we have AP courses. AP courses you can earn college credit for. So AP biology, 1.5 credits. Equivalent to first-year college biology course. Students are highly recommended to have taken honors biology and honors chemistry with a B or higher, but that is not required. There are students who have taken regular biology or regular chemistry or one of each, one honors, one regular, and have taken the AP bio. But it is very rigorous. It is college. It's like a college class that's just taught in the high school. All right. So if you sign up for it, make sure that you're ready for that. AP chemistry is, again, an AP. It's a college level class, and you also do this service part. So it's an extra half credit, and Mrs. Hemling runs that. AP biology is Mr. Tempest down the hallway there. And here you would have to ask Mrs. Hemling to get a little bit more information, but I think it was last year, it kind of got cut off with, obviously, COVID ran us into issues, but they were developing solutions to some of the problems. I don't know if you guys have heard all the trash that's in the ocean. What some chemists are doing are they're developing bacteria that eat plastic. All right, and then they spread that bacteria out there, and they eat all the plastic and help kind of save the oceans. And looking at how are we going to get all that bacteria out there and how are we going to grow it, those might be some things that you do in AP chemistry. So I know that was kind of a lot of talking. I went through PLTW and some AP courses. Any questions that you guys have right now about any of the courses? All right, more AP courses. We have AP Physics, 2 AP Physics courses that are going to run next year. If you haven't taken physics yet, then you're not eligible to take AP Physics right away. So you have to take physics first or honors physics. So here's just information. If you take an AP and a PLTW, you get these achievement certifications. It's just more things that tell colleges and employers how dedicated you are to your academics and how hard of a worker you are in school. And so it looks really good on resumes and things. So if you're taking one or the other, I would suggest maybe look at taking both to kind of get this extra component. And that just goes through, and I'll share this. I'll put this up on Canvas so you guys can review it. But there's lots of information here about PLTW and AP. So now these are elective courses. So if you pass chemistry, then all of these are eligible for you. Okay, so you can take Earth and Space Science. All right, Mr. Gerber teaches that. Students will explore astronomical, geological, and meteorological topics in order to gain a better understanding of the planet we call home. So you're going to take a look at a little bit of astronomy. You're going to take a look at geology, which is how the Earth, like rocks, and how the plate tectonics work, and then also weather patterns. Students should take and pass biology and chemistry or physics before taking the course. So you're all here, you've taken and passed biology. If you pass chemistry, you are eligible for this course. We have environmental science. So it asks, how are you interested in how humans are affecting Earth and learning about the potential solutions to the issues? This is the main focus for environmental science. Students should have already passed their bio and physical science credit. So same thing, it's just a disclaimer at the end. That's environmental science taught by Mr. Tempest down the hallway here. And then human anatomy and physiology, this is taught by Mr. Betcher. This course will focus on the structure and function of the human body and is taught in an organ systems approach. Any student interested in learning about the human body is welcome to take this course, and it is encouraged for those thinking about a medical career. Dissections are part of the second semester of this course. Students should take and pass bio and physical science prior to taking this course. So a lot of dissections in this one. I know they do brains, they do eyes, and I think at least they used to, I don't know if they still do, but they used to do a full cat. They would get a full cat and dissect it, which is it's pretty interesting. I dissected a bunch of things in college. I didn't get the chance to do much in high school, and I know some people don't really look forward to dissections, but I thought they were super interesting. Any questions about any three of these classes? All right, I know I'm bombarding you with information this morning, but I want to make sure you guys have an idea of what to choose for your science credit. So these are some other classes that count for a third credit that are not in the science like part of the science department. So natural resource management, that's taught by Mr. Gansky. All right, the conservation of natural resources is essential to the survival of this planet. This course introduces the student to the management techniques used to maintain resources as well as careers in the natural resource and environmental fields. Managing natural resources requires knowledge of land, laws, groundwater, fishery management, government, and principles of ecology. I've heard a lot of students really like this course. So you need 3 credits of science to graduate from high school. You're going to have bio, and if you pass chemistry, you have chemistry. This could be your third one. Principles of biotechnology, again, Mr. Gansky. Exploration of fundamentals. This is a rapidly developing science of biotech with applications to food and fiber industry. So some things we're doing with food, I don't know how you may have heard of GMOs, all right? GMOs are genetically modified organisms, which generally is food. So they've found ways to put more nutrients in some food so other countries don't have to buy food from other countries. They can grow it themselves and get the nutrients that normally they would be missing. It's pretty interesting stuff. Food products and processing systems, plant systems, power, structural, and technological systems. Social science. Large animal science and veterinary health. 1, again, Mr. Gansky. I don't know if you've taken an ag class, but he's got animals in the back. He's got, I think right now, a calf. They had pigs, I know, last year. They actually gave, they watched the mother pig give birth to a bunch of other pigs, baby piglets. I think it was last year, maybe that was 2 years ago. Sometimes they'll have sheep and different things in there. Learning how to take care of them and how to train them is part of the course. And then here's a new course. I'll be teaching this next year. This does not count as a science credit, but I wanted to show you guys this because I think this is a really important class. It's called Introduction to Computer Science. So Computer science is going to be learning about computers. Again, some of that coding you're going to be learning here. It's an interactive introductory course for students brand new to programming. So I know at the middle school, you're required to take some programming things. And then at the high school, we don't really have a whole lot, except for that other PLTW course I have, but you can't really take that until you have like enough math. But this is a course designed for anyone, whether you've taken a computer science introductory course in middle school or you haven't touched it ever. It is a year-long course, and there will be an AP computer science as long as students sign up for it. There won't be any next year because no one has this introductory course because it's going to be new. But if you are maybe thinking about computer science as a career field, which is just exploding, there are so many jobs in that right now, you could take this course and then that would set you up for AP computer science as a senior. Helps you to think computationally and solve complex problems, skills that are important for every student. It's a great starting point for students to gain skills and knowledge associated with computers and technology. So those are all your courses. But again, this does not count as your third science credit. It does not count. It's something that I think is super important, but you're going to have to pick one of the other courses to get all of your science credits crossed off here. All right, so I know that was a lot. All right, I'll put, here is a link in chat that you can use to view it even more. If you click on that link, you can click on course descriptions and you can see the whole course description for the booklet that I think they used to send out, but they don't send it out anymore. All right, that was a lot. All right, so let's review a little bit from last week. So we took a test on Friday. If you have not, Thursday. If you have not taken that test, you need to contact me. There's a code you need to enter in order to take it. And I want to make sure that either you take it on screen with me if you're virtual, or maybe you're virtual on a certain day, or I want you to take it kind of in person. All right, so just contact me if you haven't taken that yet. I have not put in zeros for it. As soon as I do, if you haven't taken it, your grade's going to totally tank. All right, I just didn't do it because I didn't want you to start the week at like a 25%. Okay, because that's what it's going to be if you have a zero for a test. All right, so let me get rid of this here. Let me get Canvas open. All right, so last week, just a quick review. We took that test on the periodic table. Some of the main things we talked about on the periodic table were valence electrons. Let's rewind a little bit. Can anyone tell me what is a valence electron? Yes. Good. Electrons on the outermost ring or orbital or shell or whatever we call it. And we talked a little bit about reactivity, or how atoms share electrons. So when atoms react, they're sharing or transferring electrons. And we're going to take a look at that today. So to start off, let me go student view. Don't forget to get your green check marks here. Here's the to-do list. You can click on that and see what we need to do this week. Most of it is going to be on Class Kick. We will do a few things in class together. But today's Monday, so I'm going to click on Monday's assignment. Here are the directions. We're going to go to Class Kick. So you can click on this link. Remember to always log in. Do not type in your name. I'm getting all the students off of that, because if you type your name in, Class Kick thinks you're a totally new student, and so you can't see your old work. And so students are kind of blocked out of anything that they've done before. So you're going to click this login and then continue with Google at the top, and that should get you into Class Kick. Whoop. Thank you. Here's what it looks like to start. All right, I'm going to do a demonstration to start off here. And I want you just to observe the demonstration. and then list 5 questions that you could ask or investigate after observing the demonstration. Okay, so it could be questions that you would just simply ask me. It could be questions that you could investigate in a lab. Okay, so I want you to investigate. Students online, I'm signed in as a second time. Maybe if I stop presenting here, you guys can see it. But find the other one, and you should be able to see me standing in front of the board so you can see the demonstration. All right. Watch carefully. And if you can't see, because I'm going to drop them on the table, you can stand up, you can move around, make sure that you can see what's going on. Okay. Okay, right now I want you to maybe write down a question or two. Could be anything. What is something you could investigate? Sorry. All right, if you didn't get 5, that's okay for right now. I'm going to do it just a couple more times. All right, watch carefully. All right, and see if you can get another 1 or 2. I want you to get at least 5. If you get more, you can just add them kind of at the end. All right, here we go. I'll just keep it up. Try to fill in those 5 questions. What's a question you could ask that would maybe help you figure out what's going on? It could be something that you could test in a lab, or it could be something maybe you just wanted to ask. Maybe it could be something that you just had a better view of the objects that you could. If you're still writing, that's fine. I'm just going to ask here as a class, anything that you would want me to just slightly change about what I'm doing up here, anything you want me to slightly change that might help you answer some questions, all right? Maybe like the way that I dropped them or something, anything that you maybe wrote down, something I could slightly change. Yeah. Pull one higher and one lower. Okay, I'll try that. Is there a certain one you want higher? Like the bouncy one or the non-bouncy one? Okay. Okay, that might get you to ask some more questions if you haven't gotten 5 yet. All right, I can hold on. I can hold both, maybe. All right. Good idea. Anything else you'd want me to maybe just change a little bit about this demonstration? Might help you answer or ask, or maybe just rule out some things. All right, let's go. I want us to share some of our questions. So first, I want you to share with the person at your station. All right, share with the person at your station. What are some questions that you wrote down? Maybe you could share all 5 if you wanted to, or maybe your best 2, but share more than 1. Okay, share more than 1. All right, I'll give you guys a minute or so to do that. Ready, go. Time. All right. Now you can share your question, or maybe a question that your partner shared with you. I want to get at least 3 out here in class. You can give me a question they thought was a good question. Yeah. Oh, great question. What materials are they made out of? Excellent. What's another question? Yes. What's inside of the balls? Great question. Good. Yes. Oh, do they weigh the same? What's the difference in weight between the 2? Great question. Any others that you thought were an exceptionally good question? Either they came from you or they came from the partner. All right, make sure that you have at least 5 questions listed. All right, now let's investigate something that this might seem completely different, but all of these things are going to be related here. All right, I'm going to give you a bucket at your station. All right, and I'll have to make a breakout room for the students on here that I'll be able to show you some of these things with you. But I have buckets up here, and there are 3 things in the buckets. All right, and I'll get them out for you. You can touch them. I would try to avoid touching them as much as possible. All right, because we'll sanitize afterwards, so every class is safe. All right, but I want you to look at these things carefully. So in the bucket, you will see kind of a silverish rock. Okay, that is silicon. You will see a closed container, and inside the container, it will contain oxygen. And then you will see a beaker that is open, and that is made of glass. And I want you just to make observations about each thing. All right, the observation can be obvious. All right, I just want you to get a list of observations. I would say you should be getting around 4, 5, 6 observations per object. Okay, and online students, I'll make a breakout room here for you, and then I'll kind of run the lab with you guys. Set up breakout room, 1 room. Whoops, maybe I can't do that. Here's what I'll do. Can someone confirm that you can see me on this second, Mr. Ziegler? Make sure you can put it in the chat that you can see me, hear me, or you can pop off mute.
Yeah, I can hear you.
Okay. All right, I'm going to show you the substances here. Okay, so look carefully. Oh, wait. I'm presenting, which probably makes it hard for you guys to see. Okay, here we go. Okay, this is silicon here. Okay, you can also look up a picture on the internet if you need to. This is silicon. Okay, any observations you can make about it? Try to get a few observations. You guys might get a little bit less than the students in class because you guys can't see it for real. But take a look on the internet also to maybe get some observations about it. Okay, next is oxygen. Okay, that's in this container here. Try to get some observations for it. And then lastly, here's glass, which you guys are probably fairly familiar with glass. So you might be able to make some observations based off of that. Try to get 2, 3, 4 observations if you can. Right, if you have any questions or if you're stuck or need help, let me know. All right. If you haven't, all right, you can start bumping down to question 3 in question 4. Oh, I bet this link doesn't work. I'm going to have to fix that because I think it's just like a screenshot of it. I'll put the link up there so you guys will be able to work on it in just a moment. But if you haven't, you can start on number 3. All right, we have silicon, which is Si. We have oxygen, which is O or O2. And then when you get to number 3, it talks about glass. Is both of those two things combined? All right, I'm just going to ask you some questions as you start working through here. So let me get that link working. All right, now you should see this link that you can click on your screen. You can launch it as a group at your station so you don't have all the competing noises going on. Okay. Passes. Let me get this back to you. Yeah, I can show you the demo. And so let's do this. Drag out 5 questions. I'm not sure I have 5 questions. Either you could, or you could do it. All right, just with a show of fingers, how many more minutes do you think you need to finish up page 1? If you're all done, you can do a 0. If you need like 1 minute, 2 minute, 3 minute, what do you guys think? All right, I'll give you guys a couple more minutes here. Keep working. You guys do an excellent job. All right, I'll give you about 1 more minute to kind of finish up here. If you want, I got some hand sanitizer up here if you want to come and wipe your hands down. You can put the materials back into the bucket if you haven't done that. All right. let's take a look at some of these up here. So number 3, glass is made up of bonded silicon and oxygen atoms. It's SiO2, which is the silicon you saw. That was that kind of like little rock thing. And then oxygen, you guys are probably familiar with that. It's like all around us. It's colorless. It's a gas. When we put those two things together, when we bond them together, we get glass. By just looking at glass, could you tell it was made up of silicon and oxygen atoms? By just looking at it, I would guess most people would say no. You probably couldn't assume just by looking at glass that was the other two things combined. Oh, why? Why do you think, whether you said yes or no, why do you think someone might say that no, they wouldn't be able to tell that it was both? Why would it be difficult to tell that glass is made up of those other two substances in your bucket? Maybe I'll phrase that question in another way. If I gave you a substance, or maybe what if I had a substance? I didn't show it to you, but I said it was made up of the silicon rock and oxygen. What would you expect it to look like? Yeah. Sorry, say that louder. It should look more like silicon. Why? Okay, perfect. All right, so oxygen is colorless. It's clear. You can see right through it. You don't even really notice it, so it probably should look more like the silicon than it should the oxygen. Or maybe you might think that it would kind of look like both. It should have kind of this shiny rock, kind of grayish color to it because it's made up, at least part, silicon. But what we see is something completely different. All right, watch the Meet the Elements video. There are only 118 elements that exist. Why do we have billions of different substances in the world? Why do we have so much stuff if there's only 118 things up there? We got a lot more than 118 things, yeah.
We use the elements to combine them together to create stuff.
Exactly, and when we combine the elements together, they don't always behave like part silicon and part oxygen. Sometimes they behave in something completely different. So we talked about last week these valence electrons, all these patterns on the periodic table. We see things in columns are similar. Things in a row are also have some things in common, but everything up there on that periodic table has some specialness about it. It is different than everything else. That gives us 118 elements. But now when we start combining them, we get things that are completely different. We get things that are totally different than what they would be by themselves. And so I'll give you guys kind of, here's something if you have time, you can kind of play around with. Up here for this P table, this periodic table, I used this a bunch on my videos. You go to compounds here. All right, what you can do is you can take two elements and you can put them in here and it can combine to make something. So I'll do, here's sodium. Okay, we hear about sodium a lot. It's in our diet and different things. If I click on it, here's what sodium looks like when it's all by itself. It is a metal. It's a soft metal. You can, I think, if you just had like a regular butter knife, I'm pretty sure you could cut through this. All right, you can cut the sodium here. It's a very soft metal. It gives you a bunch of information, but I just really wanted the picture here. And then if I add, I'll get rid of this one, chlorine. I click here on chlorine. This is kind of a yellowish, kind of clear gas, completely poisonous. It was used in wars to kill lots of people. It's a very very bad burning sensation in your lungs if you inhale this, even a small amount of it. But if we combine that with our sodium, we get something called sodium chloride. Now look at that, that's table salt, that's a salt. Okay, it looks different. It's not a metal anymore, all right, like it was before. It's not a poisonous gas. It's something completely different. It's something that we eat every single day. And so you can take any two substances, I think any two substances, put them together and see, this one didn't give us a picture. It talks, here it is, do this one. Oh, they don't give us a nice picture for this one either. Well, we get this calcium and oxygen together is lime, like limestone. It's kind of a white, kind of crystal powdery substance. All right, where calcium, a lot of times we'll think calcium it's in our bones, but again, it's a metal. It's silvery. Okay? Oxygen, you're probably familiar with. We just took a look at that. It's clear, but putting them together makes them totally different. So we're going to start taking a look at how things start combining. And it has to do with their valence electrons. Valence electrons control how elements are going to bond with other elements. And then we're going to get something completely new kind of at the end. So this is just kind of a fun activity. If you wanted to, you could. But that's by no means a requirement. So now, if you haven't yet, turn to page 2 in Class Kick. All right, so I'm going to let you guys kind of explore the different bond types, because there are different ways for atoms to bond together. If they bond one way versus another way, it's going to change how they behave and how they interact. So I want you to first find, and you just use the internet here, all right? I want you to first find the 4 types of bonds, all right? You will see, if you just search 4 types of bonds, you're going to see a bunch of stuff about H bonds or hydrogen bonds. I want you to completely ignore those right now. They're not truly bonds. They're similar, and we'll talk about them later. But I want you to ignore them. So you should find 4 bonds, and not a single one of those 4 should be hydrogen bonds or H bonds, okay? The next thing I'm going to want you to do is define H times. So find the definition. So bond type, whatever you find for your first one, you can put here. Retype it, all right, and then give me a definition. All right, same for 2, same for 3, same for 4. And then you're going to take a look at the valence electron behavior. Valence electron behavior. And depending at what website you go to, it might be very, very complicated description. And if you're running and you can't really figure out exactly what the valence electron behavior is, because I want you to understand it, I don't want you just to copy and paste things over, okay? If you're having trouble understanding something, raise your hand and I can either read it and simplify it for you, or I'll give you a list of options, all right? But I want you to look it up on your own and see if you can find it. Page 3 is more the same. It's the same activity. You're going to find what types of elements, and when I say types of elements, I mean metals, non-metals, or metalloids. Okay, so some of the bond types might be metals only, it might be non-metals only, it might be some of both. Okay, or it might have some metalloids in there. Well, here it says metals only, metals and non-metals, or non-metals only. Those are just your options for down here. And then 3 proper citations. So all I mean for that is the URL. So wherever you find some of this information, okay, copy the URL and paste it down here, or save the tab and do it at the end. You should have at least 3. If you have more than 3, that's great, but I want you to keep track of where you're finding that information. Okay, and it tells you how many points each one is worth. It's worth a total of 20 points. I'm going to give you guys I'll give you 15, 20 minutes to just start, and I'll check in on you and see where you guys are at. And then from there, I'll gauge how much more time you need. All right, what questions do you have right now? All right, I'll give you time to work. If you're stuck or you don't know where to go, you can use your table partner to give you a hint of what website to go to, but don't just give them answers. All right, you can work together, but don't just share answers. All right, you guys have time to work. Go.
Good question. There, a lot of times, technically, the program doctor, I will, almost, so, you should go to seven. Yes. Yeah, there's two types of programming. And depending on the website, sometimes they say.
Don't spend 25 minutes looking for the four types. If you're stuck or you have questions, raise your hand. I can come around and help you.
What you showed me on the website,
Or after you find the four, if you just want me to check to make sure you've got the four, you can call me over. You can use videos, you can use websites, whatever you need to do to kind of research and find out more about bonds.
I'm all for it. Yeah.
I might set up something where we can take maybe pictures of each type of feed and then match it to a
Yeah.
match it to a amino acid.
Okay.
And then we can give them like a base or like a DNA translated to mRNA. Eventually, this will be maybe a week or so out, but and then they start putting the feeds together to make their protein.
Yeah.
And then they can mutate it. Basically, dump out synthesis, except.
Yeah, and I think I'm absolutely gonna jack that idea up to Connors too, because we have done at regular version of time.
Yeah.
Pretty much do the sit and get style.
Yeah.
For it, but
Yeah, they're $20 per thing, so it's not bad.
no, it's not bad at
You
all.
could, I think one bucket per 4 would be easy. You could probably stretch it to 6.
That's good to know. I'm doing a big Amazon purchase, so today I'm probably gonna order the plates and all kinds of stuff. That we don't have need for the rest of the time. I'm just gonna put on a big Amazon order, so
Okay.
we can kind of, at some point I can swing down and see what we would need for CCS, so we can kind of overlap some stuff.
Okay. Here's my types of bonds. All right, real quick, I'm just gonna give you guys some direction here. 4 types of bonds. Everyone I've checked with so far has found them. We have metallic. We have polar covalent, sometimes just called polar bonds. All right, so if you see polar or polar covalent, they mean the same thing. Non-polar, covalent. Again, sometimes these are just called covalent. All right, so a lot of times if they're just called covalent, it's probably non-polar. These 2 things are just kind of the opposites of each other. And then lastly, we have ionic. Those are the 4 types of bonds that you should have for question number 1. All right, now just show me how many more questions you have to do on page 1. All right, so if you're on to page 2 already, you can do a 0, or if you have 1 or 2 or 3 or 4 or 5 on the on page 1. Show me how many more questions you have on page 1. This would be 0, 1, 2, 3. All right, keep working. I'll keep going around and checking in on you guys. Again, as always, if you get stuck, let me know. I can move you along. So, yeah. Yep, so this is ionic. So definition of conversion. Yeah, I have passive operation. So. Yes, thank you. I'm gonna give you a few more minutes. Whether you complete it or not, I just want to kind of review some of the important parts of this activity and kind of review what we talked about so far today. All right, I'm gonna call time here. If you're done with it, don't forget to export and upload to Canvas. If you're not done with it, Wednesday is a catch-up day / test corrections. You can use your Wednesday, your virtual day to complete it, or if you have a study hall at some point, you can get it done. If you have questions as you're going through it, again, you can always email me and I can help walk you through it a little bit. So just as a review, today's homework will be to complete pages 1 through 3 on ClassKick. 1 through 3 on ClassKick using this link. All right, let me get out of student view here. Couple things I want to review. Number 1, the 4 types of bonds. I put them up on the board earlier. We have ionic, metallic, and then 2 types of covalent bonds. Technically, we'll call them polar and non-polar. Some internet websites will just call non-polar just regular covalent bonds, and that's fine too. All right, but those are the 4 types that we're going to be investigating. Okay, the definitions, you're not going to probably need to memorize the definitions or go through them, but what's really important here is the valence electron behavior. So we talked about the valence electrons in our last unit. The valence electron behavior. Anyone find what happens to some of the valence electrons? What is some of the behaviors that you see from the valence electrons that help create these bonds? Uh-oh, yeah. Absolutely. Sometimes they transfer. Sometimes they leave one atom and go to another. Okay, they transfer. Everyone find the other kind of common thing that they'll do? Sometimes they transfer. Sometimes they don't fully transfer. They do something else between atoms. Sometimes they transfer, or sometimes they don't transfer. Both electrons will kind of fight, or sorry, both atoms will kind of fight over electrons, and we call that sharing. All right, so sometimes the electrons are going to be transferred, sometimes they're going to be shared. Okay, that's really kind of the only 2 options. There are different types of sharing, which we'll talk about. All right, but really the valence electrons are either going to be shared or they're going to be transferred. And that's going to cause different types of bonds, which then create different properties. All right. Now, page 2 of this, types of elements. Some bonds are going to be made up of only metals. So we're going to have a metal and another metal, and they're going to bond with each other. Some will be metals and non-metals. So we'll have some metals, some non-metals. And then some that will be non-metals only. And we're going to use all of these hints and clues to figure out what types of bonds are being produced. So our focus, all right, we're breaking up this bond unit because it's a huge unit. We're going to break it up into 3 parts. The first part we're really going to focus on. Can you determine what type of bond is occurring? All right, and if you know the elements on the periodic table and you know where the metals and the non-metals and the metalloids are, you can start determining with this. Sometimes I might tell you what happens to the valence electrons. You got to tell me what type of bond is occurring. Sometimes I might give you a picture. You got to tell me what type of bond is occurring. And then vice versa. I might ask you to say, hey, here's an ionic bond. Show me the picture that shows it's an ionic bond. Now, today was just introductory. You just introduced yourself to all these things. Thursday, we'll go through notes. We'll review everything we talked about today. And we'll spend some more kind of nitty-gritty getting into the details of the different types of bonds. All right, so that's what our focus was today. Let's see here. Anything else I need to touch on before you go? I don't think so. Any questions before you guys take off? All right, I gotta go around and spray your desk. Please clear your desk. Leave your baskets out. I'm gonna spray everything in your baskets also. If you want, hand sanitizer, you can grab on the way out. Great work today. Keep up the good work. I think that's what the whole point. Yeah, I think so. The only reason they put it in is like spray everybody.